Hi, welcome to this video. In this video, I will be talking about vector equation of a line. Now, we have learned how to derive the equation of a straight line in slope-intercept form or the point-slope form. Right? So we learned how to find the equations of a straight line in 2D, right? The xy plane in 2D. In a couple of different forms, the slope-intercept and the point-slope form. These are the two more useful, so to speak. These are the more useful ones, right? But if I have the x, y, and z plane, right, and this is a 3D, this line is a 3D line, then the equations won't be as simple as that. It will not be as simple as this. And this is when we have to use the vector equation of a line in a 3D scenario, right? So for now, we have come across that when we have a 3D scenario and we use vector to represent the stuff that in 3D, it is actually not bad, right? So let's take a look. So vector equation of a line, since it's going to be a vector, that is, of course, we are expecting a vector, right? So you'll always have a vector. It could be r. In this case, it's going to be vector r is equal to a vector a plus a t. And you see that there is no vector symbol above the alphabet t. So that is just a value, okay? The t is a value and multiplied by another vector b. So let's zoom in a little bit and understand each element of this vector equation. This vector A here, that is the position vector of a point. Position vector of a point on the line, okay? Let me write that in capital letters. On the line. So we need to make, so any point, as long as that point is on the line and we know the position vector of that point, then we can use it as my A. Alright. For vector t, sorry, not vector, for the value t, we call that the parameter. The parameter, this is just a value, right? It's any real number. Okay, any real number. So it can be negative, can be positive, it can be fractions, can be square root of 3 irrational numbers, rational numbers, whatever, right? So it's just a value, okay? Now for vector B, this is called the direction vector. Direction vector. Another easier way to understand this would be a vector that is parallel to the line. Okay, that is parallel to the line. So any vector that is parallel to the line, I can use that as the direction vector. All right, so that's it. So if your vector equation would look somewhat in that form, okay, looks quite different from our slope-intercept form or point-slope form. Okay, so this is the vector representation of a line. All right, now we'll talk about the parameter t in class. Okay, I'll talk about that. I'll explain what that is in class. But for now, just make sure you understand that vector A is a position vector of a point on the line. Make sure it's on the line. And vector B is a direction vector, which is a vector that is parallel to the line. Okay? Now let's look at a few examples. So here I have one question, and the question is in 3 parts. Okay? Parts A, B, and C. So they are linked. Okay? So that's for part A. They want us to find the vector equation of the line through 1, -1, 3. And it is parallel to negative I plus 3j minus k. So let me write down the general form. R is equal to vector A plus T vector B. So my vector A is a position vector of a point, right? So this is a point, and that point is on the line. So this is where I get my position vector. So the position vector of this point would be 1, -1, 3. If you're not sure what a position vector is, please review on your previous homework and your notes that you took from the previous classes, okay? Position vector. It is simply the origin to that point, the vector from the origin to the point. So my position vector is 1, -1, 3. So my vector R is equal to 1, -1, 3. Plus, now my vector B is my direction vector, which is a vector that is parallel to the line. And since they said the line is parallel to -I plus 3j minus k, I can use that as my direction vector, -I 3j minus k. And the t is the parameter. Just leave it there for now, and I'll talk about what that is and how to use it, how is it useful. I'll explain all that in class. But for now, this is it. This is the vector equation of our first line. Right? So I'm going to say this is R1. Cool. Now for part B, find the vector equation of the line through the points A with those coordinates and point B with those coordinates. So now I have another line, another straight line, and that straight line passes through points A and B. Okay, so I'm going to have R2 is equal to, so I'm going to start out by the position vector. So I can choose point A or I can choose point B. Let's choose point A in this case because the line passes through both points. So I can use either one of them. Plus, now because you see that over here I have R2, right? R subscript 2. So that represents a different vector equation. This is R1, this is R2. The subscript, the 1, the 2 represent that they are two different lines. So when we have two different lines, the parameter should be different as well. So what I could have done is I can put that as T1, and this can be my T2. So different parameters, different variables, so I won't confuse myself. Okay? Now, the difficult part for part B is they did not tell us the vector that is parallel. They didn't tell us that. So how do I find it? Does it mean I cannot proceed from here? Not really, because let's say today if my line looks like that, and this is my point A, this is my point B. But this is just a sketch, okay? This is not the exact plot. This is not the line, but I'm just trying to show you guys, because we know point A and point B, I can find the direction of this vector. Make sense? And that vector AB would be parallel to my line over here. Right? So if I can find vector AB, I can use that as my direction vector, which will be, I want you guys to pause the video and figure out what is my vector AB gonna be. Okay, I hope you guys have figured out what the values. So my vector AB would be -3, 1, and 5. Okay, so my vector AB is -3, 1, and 5. That's it. So here I have completed my vector equation of the second line, R2, where I have used point A over here. I could have used point B, right? I could do that too. There's nothing wrong with that. And then I have used point A and point B to figure out a vector that is parallel to this line that I have here. That is my vector AB, which is -3, 1, and 5. And I put that as my direction vector. Okay, now let's look at the last part. Part C is asking us to find the acute angle between these two lines. So this is interesting, right? So I have my first line, this is called this L1 and L2. Okay? So they want us to find this angle here. Now, in the previous classes, we learned how to find angle between two vectors, right? Which is the dot product or the scalar product, right? Where it says vector A dot vector B is equal to magnitude of A times magnitude of B cosine of the angle between them. So if I know this, if I know this vector, and if I know that vector, if this is my vector A, this is my vector B, I can figure out the theta between them using the dot product. Now in this case, since I have the direction vector, I can just use them as my vector A and vector B. I hope that makes sense to you. So we call them direction vectors because they give us the direction of the line. So I can say my vector A is equal to -1, 3, 1. My vector B is equal to -3, 1, 5. Okay? And that's it. So we're almost done here. So vector A dot vector B, I would have -1 times -3 plus 3 times 1 plus 1 times 5. Is that right? -1, 3. Oh, this is -1. Oh, almost missed that. So this is a -1. I missed the -1 there. Then this will be -1 times -3, 3 times 1, and -1 times 5. So that will give us 3 plus 3 gives us 6 minus 5. This is 1. Okay. So magnitude of A. If you use a calculator, magnitude of A is how much is that? 1 squared, that's 2 plus 9. That will be 11. And magnitude of B, use your calculator please. 9, 25, 35. Okay, so I can complete the dot product. I'll have 1 is equal to root 11, root 35, cosine of theta. So again, with the calculator, my theta is approximately 87.1 degrees. So that's it. Okay? Now, I hope you guys understood the part where I used the direction vectors. I used the direction vectors to help me to figure out the theta, the angle between them. Hope you guys found this video helpful. I'll see you in the next video. Bye bye.